Oh my goodness, I love Ed Kowalczyk. He is the former lead singer of the band Live, and I have video of him actually doing one of their songs. It's awesome. I can't believe he wants me to make copper. How exciting. Now, Ed wants me to make copper different than how you guys are going to make copper. He wants me to use 6.82 grams of magnesium and 7.34 grams of copper chloride. Okay, so that's what I have to do. So the first thing it says is write a balanced equation. So I need to write a balanced equation for what happens when magnesium reacts with copper chloride. So all I have to do is put Mg, that's easy, plus CuCl2. This is a single replacement, so magnesium is going to come in there and replace the copper, and it leaves copper by itself, and copper is what we're going to be looking for, so that's kind of cool. So this is my balanced equation, and it's actually balanced. I can double check 1 Mg, 1 Mg, 1 Cu, 1 Cu, and 2 Cls. Now yours will not be a 1-to-1 to 1-to-1. Be careful with that. Okay. Second, determine the mass of copper that should be produced. You will need to make 2 truth tables. So I'll show you how I'm going to make my truth tables to figure out my mass of copper that should, my theoretical yield, be produced, okay? I'm going to take out a nice piece of paper and I'm going to write, how many grams of magnesium? 6.82 grams of magnesium, okay? And it also was 7.34 grams of CuCl2. Those are my starting points of each of my truth tables. So I'm going to move the paper out from behind us and I'm going to bring this up. So I'm going to start with 6.82 grams of magnesium. I have to change it to moles. You just have to, okay? Because you can't compare anything in grams. So I look up the molar mass of magnesium. It's 24.31 grams of magnesium in 1 mole. I look that up on the periodic table, okay? Now I have my mole ratio. Well, remember it was 1-to-1-to-1, which yours will not be. So it's for every 1 mole of magnesium, I get 1 mole of copper. Now, moles of copper isn't what I want at the end. I want to figure out grams. So I look at the periodic table. 1 mole of copper equals 63.55 grams of copper. Now, if I do the calculation here, all I would do is 6.82 divided by 24.31 times 1 divided by 1 times 63.55. I end up getting 17.83 grams of copper. Cool. All right, let's try it the other way around. Now the other way around, I have to do my 7.34 grams of copper chloride. Then I will have to figure out the molar mass. What's 1 mole of copper chloride? Means I have to look up copper, which we already did, 63.55, plus chlorine, which is 35.45, times 2. I end up with 134.45 grams of CuCl2. Our next part of our truth table is the mole ratio. So it's a 1-to-1, 1 mole CuCl2, 1 mole of Cu. Remember, that's not how it is for you. 1 mole of copper here weighs 63.55 grams. We already looked that up, so we don't have to do it again. So now we do the math across. 7.34 divided by 134.45. And we multiply it by 63.55. And I get 3.4, I'm going to say 7 grams of copper. So now I have 2 answers. Which one's correct? Which one's the actual theoretical yield? It's the smaller of the 2. So I'm going to circle that one. And that's my theoretical yield. And I have shown my work as how I got there. That's awesome. So what's the question ask? Okay, so it determined the mass that should. We did that. The following data was produced in this lab, so we're going to use this data, okay? And it says complete the following table. Here's the mass of filter paper. Here's the mass of filter paper plus copper. This is the mass of copper, so all I would do is do some subtracting. 4.76 minus 1.52. Then I end up with 3.24 here, grams. And I'm going to do the same thing. 4.52 minus 1.46, 3.06, cool. And the same thing, 4.78 minus 1.54, 3.24 grams here. So that's my actual yield. So it says, what is the actual yield? I'm going to do an average just for the heck of it. So I'll take my 3.24 plus 3.06 plus 3.24 and I add them all up and divide by 3, my average actual yield is 3.18 grams. Explain how you found this. I got it from the lab data. So that's cool. I got that. I have an actual yield. What's my theoretical yield? Oh, I already did that. That's the question right here. The theoretical yield is 3.47 grams of copper from the stoichiometry in number 2. So that's awesome. Cool. So I have my actual yield and theoretical yield. We'll deal with percent yield later. The next question is, what is the cost to produce this copper? This is actually easier than in the chalk lab because I'm using magnesium, right? So magnesium, it cost $4.78 in 1 gram. And you know what? We have 6.82 grams. So that's easy. I can just do a little bit. Oh, it's not $4, it's 0.478. So I would do 0.478 times 6.82. And I get a number, 3.2, I'm going to say $6. Okay, so that's how much that actually costs. All right, and that's cool. So I get $3.26, but that's just the magnesium. I also have to do this for the copper chloride. Now copper chloride, it costs, oh man, it's way cheaper, 0.0655, okay, dollars for 1 gram. And we have 7.34 grams. So that's cool. So now we just have to do a little math. 0.0655 times 7.34. And I end up with 0.48 cents. Okay? So now the total, though, you have to add them both up. 3.26 plus 48 cents. That's going to equal 3.26 plus 0.48. It's $3.74 to make that copper. Awesome, I circled it, we're good to go. Now on the back, it's asking a couple things. Ed had many other people do reactions to produce this copper. Use the data to analyze which reaction is the best. Notice, you guys, yours is empty. So you're gonna have to figure out percent yield, okay, which you haven't done yet, which is actual over theoretical times 100. And you're gonna have to put in that nice little box the cost. Mine is already taken care of here, okay? So now it says explain, analyze which is the best reaction to produce copper. What are you looking for? 1, you're looking for the cheapest, right? What else are you looking for? Oh, maybe you're looking for something with the best percent yield. All right, and you need to explain why you chose what you chose. All right, ladies and gentlemen, that's throwing copper. And if you want to see Ed Kowalczyk live, I have a video for you after this. Thanks. See you later. Bye.